Okay, let's go. Containers and Kubernetes. So to introduce myself, Mark Harrison, I'm an app dev specialist. I'm aligned to the UK professional services sector, so I'm a kind of resource that you can kind of reach out to anytime if you want like app dev, DevOps type conversations. Today's topic, Kubernetes 101. So we're going to cover containers, we're going to cover Kubernetes, we're going to cover the Microsoft implementation of Kubernetes, Azure Kubernetes services, and then also I'm going to show some DevOps stuff afterwards. When we come to kind of moving stuff to the cloud, first thing as kind of developers, we want to kind of have a platform that we can just focus on the application. There's no kind of value managing complex infrastructure. And that kind of leads to lots of choice. So a lot of my time I spend around talking about things like app service, PaaS type offerings, as serverless type offerings. So the idea that you just kind of take some code and you publish it. The infrastructure just spins up as and when needed. And then the other conversation is kind of containers and orchestrators, which is what we're going to focus on today. This is the area that we're going to drill in. So we're going to touch on containers, kind of talk about what they are. Then we're going to show how we can run containers in container orchestrators, in particular Kubernetes. And then we're going to look and see how we can kind of wire this all up with DevOps. So let's start. What is a container? Well, a container is a way that we can package up our application into a single file, and then it's got all its libraries and dependencies inside that file. And then what we can do is actually execute it. So it's become a really popular way of packaging up apps, moving them around, and then kind of executing them. To kind of understand containers, let's look at virtual machines and see the problem that containers is trying to address. This diagram here is showing virtual machines. It's running on a virtualized hardware, and your application is running on top of the operating system. And people like to create virtual machines. Every time they create an app, they like to create it in its own virtual machine, so there's isolation. So each application doesn't kind of interfere with the other application. Now, the problem with this is you can end up with a lot of virtual machines. And virtual machines these days they're big, they're resource hungry, and to run a lot of VMs can take a lot of kind of resources. So in comparison, what a container is instead of running on virtualized hardware, they run on a virtualized instance of the kernel. So the idea is that you could have many containers all running on a single OS kernel. So this has still got kind of packaged up in this kind of isolation boundary. So one application can't interfere with another application, but they're running on a single instance of the OS kernel. Now, there is a small part of the operating system that's inside the container. Kind of most of the operating system, there's just one instance on the OS kernel. And you've still got that kind of benefits of isolation. So one application can't interfere with another application. So that leads to this container. It's a single file. It's known as the container image. It's packaged up all those dependencies, provides that isolation, and then got this kind of portability. So what you can do is take a container and can run it on any container runtime. As you saw in that graphic, there is a small part of the OS that goes into the container. So we do have the concept of Linux containers and Windows containers. So when you package your application, you've got to kind of mandate, is it a Linux container or a Windows container? And so the benefits of using containers, a lot of it is about cloud density. We can squeeze much more into less resources. So we don't have all those numerous virtual machines. We just got one instance of the OS kernel that they're running on. So it enables this agility. We've got this portability, so it's easy to move things around, and then can scale up the container images as and when needed. So it becomes really popular in kind of microservice-based architectures. So let's switch to a demo. Let's show you how hard is it to create a container. So I've got Visual Studio here, and I'm going to create a new project. Let's create a .NET Core project. Let's call it a name. So I'm just using standard .NET to create a kind of core skeleton of a website. And if you're a .NET developer, this will be quite familiar with you. What I'm going to do is just go and edit the home page. Happy Friday, just to show that I've made a change. And then what I'm going to do is put in a piece of code that does this. Using IntelliSense to help me code it. Okay, let's save that. Let's run our application. And what we're doing here is we're running this application. So as a developer, I'm running it on my Windows laptop. So if you're familiar with all this, it's going to spin up a kind of instance of, I think it's IIS Express, and we're going to be able to run and debug our application. So this is all standard stuff. We've got no containers running at the moment. And here's my app. So what we can see here, this is running on Windows 10. Let's stop that. So the question is, how do we now package this up as a Docker container? In Visual Studio, we can just basically add Docker support. And we have a choice. Do we want this to be a Linux container or as a Windows container? And we're going to go to Kubernetes. Kubernetes can run Windows, but Linux is a little bit more lightweight, so we're going to choose the Linux option. And what we've got here is added to our project a Docker file. So a Docker file is the way that you can package up your application. I'm just going to change that to release, so it actually puts the application into the container, but I'm going to now run it on Docker. We're building the container. And of course, the normal way that you'd be doing this is you're going to developing locally and you're checking in your code, and then you'll have DevOps pipelines that will be building these containers. So, thing to spot here, I'm still running on my Windows laptop, but it's showing that we're running it on the Linux environment on top of my Windows machine. If I go to a prompt here, there's the Docker tools. If I do Docker images, we can actually see this is the app we just built. So this is the file, and it's 217 megabytes. This is the file that contains my application, all the libraries, all the dependencies that we can kind of move around. And so that's what our kind of DevOps processes will be pushing around into, dev staging production environments. And you can see it's a lot lightweight, 217. Compare that to some of the sizes of the virtual machines these days. Hopefully you can see from Visual Studio, it was really easy to change that kind of Windows packaging up into a Docker container. All I needed to do was right click on the project, add Docker support, and rebuild it. There is the concept of a container engine and a container orchestrator. So the container engine is what's managing the life cycle of running that container image. So it kind of handles interaction with the runtime, the host system, handles things like the execution, talking to things like storage and networking. There are a few container engine technologies out there, but certainly in the enterprise space, kind of Docker is the kind of the de facto standard for running containers. So there's also this term container orchestrator. In a real kind of application, you're typically not going to be running a single instance of your application or your container. What you might want to do is run many instances of it. You might want it to scale up, scale out, and then scale back down again based on demand. And you need something that's going to automatically do that, kind of monitoring what is the demand on your container and then scale up as appropriate. Other things you might want to do is things like rolling updates. So you've got your application running, you might have 5 instances of your container, and you want to go from version 1 to version 2, what you want is some tooling that's going to basically drain each one in turn and then update it to the next version. So those are the sort of things that container orchestrators can do. And when it comes to container orchestrators, there's quite a lot of choice. So, I've listed some of the native Azure services around running containers. So there's App Service, there's Service Fabric, there's Kubernetes that we're going to look at. There's Red Hat offering. It's kind of based on Kubernetes. There's also lots and lots of partner offerings in this space, and they all can run on Azure. This is what a kind of typical CI/CD kind of process might look like. And we'll drill down into this a little bit later, but the idea is you've got your developers developing locally, and then at some stage they're going to check their code into a kind of Git repo. And then you're going to have some sort of CI kind of build process. Ideally, it's going to be Azure pipelines, GitHub Actions, but it could be whatever. And then what it's going to do is basically take that Docker file that I kind of showed in the Visual Studio, and it's going to use that to build the Docker container. And then that container is going to then be pushed into what we call a container registry. So this is a repository where all your built containers can reside. And you might have different versions. So you might have version 1, version 2 of your container, and they're all stored in the container registry, ready to be deployed. And that's where you've got your CD, continuous delivery. It's going to then deploy that container out into a runtime of choice. And it could be Kubernetes, it could be OpenShift, it could be App Service, it could be any of those options that I showed on the previous slide. And in most cases, you do not have to change your container. It's the same container, irrespective of where you're actually deploying it. There might be some configuration around it. And, Kubernetes configuration is different to App Service, but basically it's the same container. From a development point of view, it doesn't make a lot of difference where the container is going to be. Container registry. So as I said, this is the repository, and there's choice where you do it. So Docker Hub has got its own kind of public repository where a lot of kind of commonly used applications, they store them up in Docker Hub. Azure's got its own repository, own container registry called Azure Container Registry. And it often makes sense, if you're deploying your applications into Azure, it makes sense for the container registry to be in the same data center that the target applications are going to run on. So let's have a look at Azure Container Registry. Here's my Azure portal. If I go to, I've got a resource group called ACR. I have this Azure Container Registry here. And the key, there's various things in there, like how do you access it and webhooks, etc. So the key part is the repository area on it. And here you can see all the images that I've actually got stored in there. So if I pick one of these, let's pick this one, you can see we've got different versions. We've got the latest version, we've got version 197, 198, and I've tagged it with some other IDs. But basically, each application has a container, and the container could have various versions on it. And they're all sitting in the repository in the ACR, ready to be pulled into the runtime. Let's go back to the command prompt. What I need to just do is log on to the Azure Container Registry. Okay, and I'm going to push our application that we built earlier up into the Azure Container Registry. Now, there's a few commands to do this. Again, it's not real world, as in normally your DevOps pipelines would be doing this, but I'm just going to do it manually. So I'm going to say Docker tag. What I need to do is create an ID of this application here. And I need to call it that's my Azure Container Registry. Then I'm going to give it the same name. So now if I do Docker images, You can see on my machine, I've got this one. You can actually see it's the same image, but it's got a different name. And then what I can do is take that and push that into the Azure Container Registry. And the other thing to kind of note here is a Docker image is layers, and it kind of pushes and pulls things around in layers. And if the target has already got a layer, it doesn't do anything. It just uses what it is. So it's often the case where you might change a small part of an application. It's only changing one of the layers. And so when you're pushing and pulling these things around the place, although it says it's 217 megabytes, it might not actually be needing to move that amount. So if I go now back to fresh, you can see I've now moved my application, the one I created 20 minutes ago with Visual Studio. I've now got this, and I've got the latest version. That's sitting in our container registry, ready for our application to use. What we're now going to talk about is Kubernetes. If you can understand all these terms, you're pretty on the road to understanding what Kubernetes is about. So let's just do a few diagrams to explain these things. We often talk about a Kubernetes cluster. So Kubernetes cluster is a number of virtual machines that are going to do the kind of the handling of your containers. And they're split into two groups. There's the master VMs and the worker VMs. The worker VMs are going to run your containers. The master VMs are going to look after the state of the cluster and make sure everything is up and running. The next thing to talk about is a node. A node is a VM. What's going to run your containers. So we often talk about, for example, a 3-node cluster. That means there's going to be 3 VMs that are going to power your containers. We also talk about a deployment and a pod. A deployment is the deployment of your application or your container. So for example, we might have a website wrapped up in a container. We might go and deploy that website. The pod is the instance of that deployment. In that diagram there, you can see Kubernetes is what's called a pod, and inside that pod is your container. You can run multiple containers in the same pod, but it's more common just to run a single container in that pod. In this case, what we've got is we've said that we want 3 replicas of our container. We've made a deployment, but we said we wanted 3 pods, 3 instances. So we've spread the load over multiple VMs. And it's job of the replication controller to look after that and make sure that you've got the right number of pods. Now you can put auto scaling in, so the number of pods kind of changes based on the traffic that's hitting the cluster. At the moment, the container is inside the cluster, but there's no external connectivity to it. And also, as I said, those containers can change their location. If you're scaling up and scaling down and moving things can automatically move around. How does anything communicate with it without knowing where it actually, what the actual network address of it is? And so that's what kind of leads to the next bit, the idea of a service. A service provides that kind of common endpoint to your application or to your container, irrespective of where your containers are actually running. So you always communicate with the container via a service. Now you can have services that are external facing as well. So if you want to put your website on the internet, you'd create a service with an external load balancer. Now you could have multiple services, you know, multiple containers, and then the idea is you can create an ingress controller, which then fronts multiple services. And that's good if you're exposing things to the outside world. It means that you only need to worry about things like certificates in a single location. Config map and secrets, so we'll see that in the demo, but basically any of the configuration we can put into a file, we can load secrets, and then our applications can look at the config maps, look at the secrets, and then configure themselves appropriately. We have the concept of namespaces. What we can do is carve up our cluster into specific groups. If you're a team of developers, you might each have your own namespace. So you've got your own kind of slice of the cluster. There's always one called Kube System. That's where the kind of the operating components of Kubernetes runs, but then you can create your own additional namespaces over and above. So in this case, you might have a dashboard component that's running in Kube System, but your own application might be running in its own namespace. One thing when you come to configuring your application is there's a lot of definitions in files, in YAML files that are often called the manifest. It's an application, it's a kind of an extension on Kubernetes called Helm. And what that does is it kind of, because you can end up with a lot of these kind of YAML definitions, what you can do is group all these into what we call a chart, and then Helm will go and deploy that chart. So a good example maybe is something like WordPress. Well, WordPress has got both the front end website and then the back end database functionality. What we can have is a Helm chart for WordPress. Then we can just go to Kubernetes and say Helm install WordPress, and it will go and look at all the YAML definitions and go and deploy all the various components. So that's standard Kubernetes. What's different about AKS? Normal Kubernetes, we've got master VMs looking after the cluster. If you go to AKS, those master VMs have become what we call the AKS control plane. So we are insulating customers from the complexity of worrying about the masters. That's just part of the service. And we don't charge for the control plane. If you install standard Kubernetes, you've got to pay for those VMs. In the case of Kubernetes, that control plane, there's no kind of charge. So it's just a lot simpler to run Kubernetes. All you really do is got that interface into your compute environment, and then it's going to do all this kind of things like make sure it's kind of upgraded and fully patched. Okay, let's go to a demo. This is my Kubernetes cluster. I've already created it. I will show you later when we come to the DevOps how this got created. But this can just show us some of those terms that we looked at, namespaces, workloads, that's where we displayed the various pods, deployments. We can look at the services. So all the things that I kind of called out. The node pools, remember I said that you might have a 3-node cluster. Well, here we've got, as I said, a 3-node cluster running of Linux. So one of the tools people will use is something called kubectl, and that gives you command into controlling your cluster. So for example, one of the things we can do is kubecontrol get nodes. And you can see what we've got here is a 3-node cluster. What we can also do is things like get deployments. I've got no deployments. Likewise, I've got no pods running. If I do say get pods, but tack this on the end. What it's showing is that there is a couple of namespaces. When I said there was no deployments, there was no deployments on the default namespace. But you can see we've got a number of Kubernetes, the main kind of control is running in Kube system. What I've got is a application, it's an API app that's going to show colors. And to go and deploy that, we have this file here. And so it's a bit of YAML, and it's basically saying, go and deploy this container, version 1, it's got a tag, and I want 3 instances of it. So to go and deploy that, what I need to do is so it's a kube control, it's an apply, and it's going to specify that YAML file. So now if I do get deployment, we can see it's deploying my container. If I display pods, we can see we've got 3 pods. If I said kubectl delete pod that, so I'm going to basically kill that pod. If I do get pods, see I've got 3 still running, even though one kind of crashed, because the definition said you've got to have 3 instances of that pod running. What it's gone and done is created a new instance of it. Now at the moment that pod is all inside the cluster. We can't communicate with it. So to communicate with it, we've got to create one of those services. So there's this command here that says go and create a service. So now if I say get services, so we've got a color API service. We haven't yet got an external IP address on it. It takes a little bit of time to create that address, that external address. Let's just wait a few seconds. Okay, we've got an external address. So if I bring up a browser, go to that address /swagger. So that is a public IP address. Any of you could go and hit that. It's an API app. I'm just going to the Swagger UI. We've got a random color coming back. So what I've got is, if I take that URL and go to this little test harness, what I can do is configure it. Okay, so we're hitting that API and we're coming back with a random color and we're just lighting up one of those lights. And what I'm going to do is just put that to the side and go back to this. What we can see is we've got 3 pods running. What I can do is I can go kubectl edit. We're going to edit the manifest of the deployment color API. And if we look down here, this is where it defines the number of replicas. So if I change that to 5, file save, and then do get pods, what it's now done is spun up 2 extra containers to handle this workload. Now, another one that I could do, let's say we're running version 1 of our API. Let's say the business has now created version 2, and we want to do a rolling update, but we don't want to bring our application down. We'll go down to here. There, that's where the image is specified. What I've got is a version 2 of my API sitting in the registry. I'm now going to save that. If we now look at the pods, what we're doing is this rolling update. We're changing each one in turn to version 2 of our API. And you can see it's now starting to turn from flavors of green to variants of blue. So we're now running version 2 of our app without bringing anything down. We've just done that rolling update. So that's what Kubernetes has kind of offered us. Now, when I pulled that container, I pulled it from the Docker Hub, and there's no kind of security around that. The one that we created in Visual Studio was in Azure Container Registry, and we need a ID to get to that. So what I've done is I've already done this, but if I've got what's called a secret. So the key to get to the Azure Container Registry, I've created as a secret. And if I show you the manifest to create our application here, I need to remember what did we call our app? Mark Harrison app. Change that to. So this time it's coming out Azure Container Registry, but we've also specified this, which is telling us to use these credentials to get at Azure Container Registry. So let me save that. We're now referring to that YAML that I just showed you there. So if we now do get deployments, there, it's now spun up the 3 pods. We need to remember this is only inside the cluster at the moment. We need to expose it externally. Got that. Let's watch the service. We need to wait for an external IP address to come. Okay, it's been allocated. Again, that's a public IP address. All of you can kind of hit that. Again, it just takes a bit of time to warm up. Yeah, you can look at the log inside the pod. There you go. This is the same app that we created in Visual Studio when we started. Notice again, it's running on a different variant of Linux now. It's running on Ubuntu, but it's the same app we wrote earlier. So we pulled it out of the Azure Container Registry, we've spun it up as a deployment, it's scaled out to have 3 pods, and then we're giving it a public IP address. Let's talk about DevOps. I mean, I guess you all know about DevOps. You know, it's this engine that drives innovation, doing things kind of faster, better that you can do with traditional software approaches. And we've kind of seen this diagram to just repeat ourselves. What we did was we created that app. We had a pipeline that built a container, and then we did, in our case, we deployed it out to Kubernetes. If you want to get started with this is a really great way of getting going. So if you go to the Azure portal and you type DevOps Starter, what you can do is follow this wizard. The first thing you have to do is select DevOps or GitHub, but I've chosen Azure DevOps. I've then chosen .NET. Again, you could choose some of the other options on there. I've chosen .NET Core. Then I've chosen the Kubernetes service. You put a few values in and say go. And then what it does, it kind of creates this Azure DevOps project, which has got the repos for both the application and the infrastructure as code. And then it's got the pipelines to build the application and then deploy it. Let's show you that. So if I go to DevOps Starter, so this is where I say if you want to create a new one where you can follow that wizard, make sure you choose Azure DevOps. I've already done this, and then this is what it created. It's kind of created this dashboard that gives me my CI/CD state. It gives me my link to my Kubernetes service. It's got application insights. So what it is just a really good place to start learning about this, because you can spin it up really quickly. If I show you the repos, the way we've got the repos here, we've got 2 folders at the root level. We've got our application, and then we've got the ARM templates to go and deploy the Kubernetes cluster. And then what we've got is our application. We've got the so this is just this wizard will just create a sample application in there. And then what it's got is, I kind of touched on earlier the concept of Helm charts. The idea is what you can do is package up your application, because there's typically a lot of YAML. You know, you've got a YAML for your secrets, you've got one for the service, you've got one for the deployment, you might have ingress. You can end up with a lot of YAML for your application. Keep the YAML inside the application kind of folder, and then as part of the pipelines, look at the build pipeline, what the Docker file in this case is doing the .NET build, and then it's pushing it into the Azure Container Registry. Then the other thing what it's doing is it's packaging up the YAML to create the Helm chart, and then it's pushing that out in as a build artifact that will then kick off the release pipelines. And edit the release pipelines. It only creates a dev environment. You could have a staging, production, etc. If we look at the pipeline, what we can see is we're doing the infrastructure as code, just to make sure everything's in a good state. Then what we're doing is a Helm install. So the Helm install is referring to the charts. The charts in turn are doing the connection to the container registry and referencing the container and the version of the container. Really easy to get this all wired up by just running that wizard, and it's good from a learning point of view. Any questions?
I just wondered if it's possible to get access to the repo for that color web application. I thought that was...
Yeah, it's all on. Go GitHub/Mark Harrison. So it's on there.
What would you do about sort of cluster monitoring and those sides of things?
Yeah, there's choices. So there is some native Azure options around this, which will start creating log analytics, and then there's kind of various solutions around that. There's a certain amount out of the box, and all this can be pushed into log analytics, and you can start doing alerts, just using standard Azure tooling. Now, that said, I think a lot of people in the Kubernetes kind of ecosystem, they're very much into Prometheus and Grafana. So if that's your kind of tool choice. So one of the things that Microsoft have done with AKS is they've done nothing to make it a Microsoft version of AKS. It's very much taken a downstream from the Kubernetes project. Kubernetes has got a large ecosystem of tooling around it. If people prefer the more kind of native way of Kubernetes type tooling, it will support all that. But you've also got, the Azure log analytics, and if you're .NET developers, you're probably using App Insights, and so you'll log into all that as well. So I guess you've got choice.
Yeah, a question about rolling updates, So obviously you demonstrated there that it helps to automate that. But the thing with any update is it normally comes hand in hand with schema changes to a database, which tends to be the bottleneck that, brings down the application, because you've got to do that. I'm guessing it's not really going to help us manage that sort of thing. The database is still going to be the problematic area, I guess.
Yeah, very much so. It's a good call out. I mean, there are certain scenarios where you can do a rolling update, but equally there are scenarios where it's not going to work. So, yeah, and I always think in DevOps, database schemas is probably the hardest thing to accommodate. If you're doing a rolling update and your APIs have changed, you can't just do it blindly. You've got to think. You're absolutely, your question's spot on. It works for certain scenarios, but not all.
Just pick up very briefly actually on that database upgrade one. One of the nice features that you can get in Kubernetes is when you define your pods, you can say a pod is made of more than one container, and then you could have one container doing a migration, and then that pod, when that is done, it then marks, so when that container is done, it will mark that pod as ready to serve traffic. So you can include like a database migration if you're just like adding a field, for example, saying lightweight. And so you still get all the rolling updates, and the deployment of your pods does the database upgrade as well, and then it can use that same kind of connection. But there's pros and cons to doing it, but that's just something that you could do.
Did you say it was using base 64? I didn't say it was using base 64, but it does. You're absolutely right. Now, what I showed you was using a Kubernetes secret. There is actually a better way of doing it. You can actually wire it up to Key Vault. I don't think the Kubernetes way is super. It's called secret, but I don't think it's super secret. If you put it into Key Vault, then it's a better way of doing it. It just needs a couple of other tweaks in the manifest to do that. It was just an extra hop from a demo point of view. I probably should have called it out at the time. With Docker Desktop going to be paid, we are trying to use Docker on WSL2 for Ubuntu. Any plans for visual without? Yeah, I know there's lots of internal discussions about the fact that Docker is starting to be charged. Some people are saying the Docker payment is worth it. They've got to survive, they've got to pay their bills, and they do a good job. So paying whatever it is not unreasonable. Just say one other thing around that. So in addition to Docker, there is also what's called Moby. Now, Moby is the actual open source container runtime. Docker is just their implementation and their tooling around it. AKS doesn't actually use the Docker runtime, it uses the Moby runtime. So it actually uses the open source version of that container runtime. Emails on the screen, so just, if you want further dialogue, discussions, questions come up afterwards, then yeah, just reach out.